Okay, here's a problem that involves Newton's laws, but for an object that is going in a circle. Um, okay, so here's a circle and here's a car going in a circle. So here's the problem statement. A car is going in a circle in the horizontal plane. Okay, so this is the horizontal plane. So gravity is perpendicular to the plane. So into the plane is gravity. And this is basic, this surface is basically the earth. And the car is going on a horizontal plane in a circle. And you're given that the speed is 20 meters per second. The rate of change of speed is v dot, 5 meters per second square. And then the car interacts with the ground only through friction and normal reaction, I guess, should be how it's written. Let me bring this whole stuff down. Only through friction, which is horizontal, and normal reaction, which is vertical. Okay, so those are the only forces between the ground and the car. And then you're asked to determine the frictional force between the car and the ground, basically. And you're told that the mass m is 1,000 kilograms, the radius r is 20 meters for the circle, and you assume that the car is a particle. There's no wind resistance. All these things are given. Okay, so all these things are given. So how do you solve this problem? First of all, what is the free body diagram for this problem? Okay, in the top view, what are the forces? Okay, perpendicular to the top view, sort of into the ground, is gravity, and then opposing gravity is the normal reaction. But those forces do not appear in this horizontal plane picture or the top view because they're perpendicular to this picture. In this picture, it says that basically the only force is the friction between the car tires and the ground, okay? And the friction could be in some weird direction. Like we don't know what direction it is going to be in. And it's going to be in some direction, okay? Or more generally, if you want to copy and paste this, we can decompose this frictional force potentially into, well, let's pick a coordinate frame for this problem. What kind of a coordinate frame might we want to pick for an object moving in a circle? Well, we can pick tangential, normal, or polar. Polar would be the simplest thing to do. E sub r and E sub theta. So that's the coordinate frame. And let's actually write down the components of the frictional force F sub r and F sub theta in the tangential or the in the azimuthal and the radial direction. This is the radial force, this is the force in the theta direction, and maybe it's entirely radial, maybe it's entirely in the theta direction, but because we don't know what it is, we just leave it as such, okay? So that's a free body diagram for the top view FBD. Okay, now how do we proceed? We can try to write sum of all forces equals mass times acceleration in the horizontal direction. Okay, the sum of all forces, this thing, is just, well, in the horizontal direction, there are only these two forces. We just say F sub r, ER, plus F sub theta, E theta. And that's going to be equal to mass times acceleration the acceleration in polar coordinates for an object moving in a circle is basically minus r theta dot square er. This is the centripetal. And then plus r theta double dot e theta. This is in the tangential or theta direction. Okay. We could have done tangential normal as well, totally fine. So what is given? We are given that v is 20 meters per second, but we have things in terms of theta and theta double dot, or theta dot and theta double dot. So given v equals 20 meters per second, r equals 20 meters. What is theta dot? Given these two things, recall that it's going in a circle. It's going in a circle, so if you're going in a circle, what is v? So v is v e theta because, and it's also equal to r theta dot e theta. Okay, so if you recall, it's going along theta direction and it's equal to r times theta dot. That's the velocity magnitude or component along e theta direction, and that's also equal to v. Okay, so basically you have v equals r theta dot, which implies theta dot equals v over r, which is 20 over 20, which is equal to 1 radian per second. Like we said, radian is kind of a fake unit. You can just say 1 per second s power minus 1 if you want, but you can also leave the radians in if you want. Anyway, so theta dot is 1 meters per second, 1 radians per second. So we know to plug it into this equation, we know r, 20 meters. We know theta dot now. What is theta double dot? We're actually given v dot. V dot is basically, well, if v is r theta dot, v dot is r theta double dot. Implies theta double dot equals v dot divided by r. So v dot was 5 meters per second square. So 5 divided by 20, which is 0.25 radians per second square. So we can use these two things. So we say A equals minus 20 theta dot square, which is 1 square, ER plus R theta double dot, which is 0.25 E theta. So you're just plugging these quantities into this formula. This is basically the polar formula, polar acceleration. Okay. So we have equal to minus 20 ER plus 4 E theta. So sum of all forces, which is basically FR ER plus F theta E theta, is going to be mass, which I think we said is 1,000 kilograms, times acceleration, which is 20 ER plus 4 E theta. And I guess we multiply through, so we have minus 20,000 ER plus 4,000 E theta. And this is all in newtons. And this is basically equal to the friction force. And if we want the friction force in the radial direction, it's going to be 20,000 newtons, and friction force in the tangential direction or the theta direction is going to be 4,000 newtons. Okay, radial force component and then the tangential force component. Okay, this radial force is basically the centripetal force, which keeps the car going in a circle, and this tangential force is the thing that actually provides the acceleration of the car around the circle. Okay, so this is the centripetal force. And this is, provides acceleration, provides increase in speed. Okay, recall again that acceleration has two parts, one part that has to do with changing speed, another part that has to do with changing direction. And similarly, the forces have those aspects as well. This force provides change in speed, this force provides the centripetal force, namely change in direction. And surprisingly enough, this is the friction force, right? The friction force is the only force between the tires and the ground. And usually you think of friction as something that decelerates or drags on an object. But if you think about it, friction force is also the thing that allows your car to accelerate forward, etc. Because the only thing that is sort of mediating the interaction between the ground and the car is the friction between the tires and the ground. And the friction between the tires and the ground is the thing that accelerates the force or the car forward. Okay. Okay, so I guess we'll stop this video there.